Hello, I'm Doug Atkinson here at Solutions Review, and I want to thank all of our moderators, expert guests, and solution sponsors for participating in these Inside Jam panel discussions. This has been a big year of changes with the launch of the all-new, always-on InsideJam.com community site. For the past 4 years, everyone here at Solutions Review has been leaning in to build the Inside Jam into a celebration of enterprise technology, with best practices, expert analysis, and solution showcases. And we want all of you to join us there to keep the jam going into the new year and beyond. If you haven't joined Inside Jam, please do. And if you already have, take a moment to invite some of your colleagues. And again, thank you all for being here and enjoy today's discussion.
Solutions Review presents Inside Jam, a social media community for enterprise technology. Hello and welcome. My name is Jonathan Paula. The Business Intelligence Inside Jam continues with another stacked group of people, which you just saw momentarily there. How to use AI to enhance data engineering. Robert Eve, Arnab Barzan, Clinton, Dr. Sue, and Prashanth joining me live from around the world to talk about this great topic. Unfortunately, Arnab just dropped out of the show. Hopefully he'll find his way. Oh, here he is. Never mind. He is back. Thank you all, one and all, for being here. Really appreciate your time. Robert, you've agreed to moderate yet another panel for us. Appreciate that. Let's let you start things off with some opening remarks.
Yeah. Hello, everybody. Welcome to How to Use AI to Enhance Data Engineering. AI, man, is AI disrupting everything these days? IDC certainly thinks so. They have a recent survey showing that half the large organizations that they've surveyed already see Gen AI disrupting their business. So the question is, are you going to be one of the disruptors, or are you going to be one of the disruptees, right? So today we're going to talk about how AI is disrupting data engineering and how you can take advantage. And why focus on data engineering, really? What makes that important? Well, there's really two reasons. First of all, your data engineering teams, they're already overloaded with the workloads and their backlogs. And how can they possibly do more than they're already doing, be more productive, and do the new data sets and data pipelines required to provide AI applications? And the second is, AI can actually be a big part of the data engineering backlog, solution to that data engineering backlog problem. AI itself as an enabler to these data engineering tools. And these are starting to be mainstream now. So it's really a great time for the audience to learn about these tools and capabilities. And really it starts with giving you capabilities to solve problems and understand problems. Observe data engineering problems like poorly optimized warehouses and pipelines that are adding to your costs, your cloud costs. Underperforming queries that certainly frustrate your users. Tooling, AI-driven tooling to help you understand the data and the metadata anomalies that are preventing your AI models from lead to incorrect decisions and actions, and more capabilities that we'll discuss. And not only are these AI-driven data engineering tools discovering these problems and reporting them, they're also now can fix some of those problems for you automatically using these AI capabilities. So observe and fix, observe and report, or observe and report is one thing, but observe and fix is even better. Wouldn't that be nice? So what's the benefit of doing this? Certainly better data engineering per se, and using these better capabilities, but also freeing up time for your data engineers to do other important work, whether it's in analytics or AI or wherever else your business needs. So let's kind of review our agenda. First, we'll start by asking the panelists to identify some of the data engineering workloads that are ripe for AI-driven disruption. So we'll start with that. Second, we'll talk about how to understanding these AI-driven data engineering tools and how they can help you address those workloads. And then we'll close with more practical advice, counsel, focusing on the best practices, starting points to ensure your success. So let's meet our panel members. Jonathan.
Yes, thank you very much for that opening introduction, Robert. Let's go around clockwise and get to know all of our panelists. 30 seconds or so. Tell us a bit about yourself and what excites you about today's topic. And we'll start with Arnab.
Hello, everyone. My name is Arnab, Vice President Data Engineering at Tredence. I've been with the firm for the last 6.5 years. We solve the hairiest of the different technology problems at Tredence, focusing on last mile adoption. Happy to be here today, dialing in from Dallas. Out and out data engineer. Have been working with new age platforms like Databricks, Snowflake, etc. Have seen how AI has disrupted our world, and happy to share more as we go along. Thank you.
Excellent. Thank you very much. Barzan.
Hi, everyone. I'm Berzam Mozaffari. I am a co-founder of Kibo, co-founder and CEO of Kibo. Prior to starting Kibo, I was in the academic world. I was a professor at the University of Michigan. So super excited about today's topic. I've actually spent the last decade and a half of my career at the intersection of doing research at the intersection of AI, machine learning, and database systems at places like University of Michigan, MIT, a couple of other universities, as well as a number of companies, both small and large. So whenever people are talking about ML or data or databases, I naturally get excited. So looking forward to this conversation.
Excellent. Thank you very much. Clinton.
Hi, thank you so much, Jonathan. Bob, it's great to be here with you today and everyone attending. I'm Clinton Ford, FinOps Champion and VP of Product Marketing at Unravel Data. I've spent about 15 plus years building and launching cloud data products, and I'm really passionate about unifying data science, engineering, and business. Looking forward to being here on the panel today with you.
Prashant, you're up next.
Hi, Jonathan. Hi, everyone. My name is Prashant Sotekal. I'm a consultant, author, and a professor. I've consulted for over 80 different companies, including the big ones like Shell and P&G and Apple, but at the same time, small companies as well. I'm an author. I've written these 3 books behind me. I've written many blogs for Forbes and CFO.University and many other places. And lastly, I'm also an adjunct professor of data analytics at Rice School in Madrid, Spain. This topic is exciting to me because what I have seen in my consulting world is almost over 80% of the time and effort in data and analytics is spent on data engineering. And AI, I believe, is going to play a big role in reducing this time and effort. And that's why I'm interested here to learn from the other panel members and also to share my perspectives on how AI can improve data engineering.
Excellent. Thank you very much. Over to Dr. Sue, last but not least.
Hello, good morning or good afternoon, wherever you are, or good evening. I'm excited to be here. And, my background is actually not in AI and ML. My doctorate is in healthcare and stats. But I've learned about AI and ML, and I'm excited to be here for the simple reason that I knew that just being in this panel alone, I would gain a lot of insight. And I'm happy to share some of the hands-on experiences that I've had. So similar to Prashant, I've worked in large consulting firms, and I'm not going to name all of them, but the Big Four and others. And I think part of what Prashant just said is maybe 70 to 80% is around that data engineering workload. I also want to just quickly add that I want to also put this in context of the business outcomes, because of data engineering, I know that that's the focus, but I want to tie it to what the business outcomes would be. So happy to be here. Thank you.
Great.
Thank you for being here, one and all. And let me bring Barzan back in, although I think there's something in front of his camera right now. Barzan, are you still there? Or is that, there we go. You were hiding behind a virtual background. All right, great. I'll let you kick off the show now, Robert, with the first question. And I'll see you back at the end.
Thank you. Well, why don't we start out with a real simple question? We'll make a list. What kind of data engineering problems are good candidates for AI, and why? Arnab, let's start with you. And we're going to make a list. I'm going to write everything down.
Sure. I'll start off with the most common one I'm seeing these days. It's migrations, right? While when you're moving off on-prem technologies onto the cloud, especially when you're doing those kind of migrations. What used to happen is people used to write normal converters, and the converters, etc., used to take a lot of time to build and then do the conversions. Now with generative AI coming in, can we think of a world where we can generate the cloud mappings? Can we think of a world where we can do schema migrations? We can move data independently just using AI. So that is what in my mind is an extremely good candidate.
Wow, that's a great one. Barzan, what would you add to the list?
I think the way I look at sort of what's ripe for AI or ML, I usually ask myself two questions, like what can be automated and what needs to be automated, right? Whenever you have the intersection of need and potential, I think that's how I sort of define ripe. So if I go by that definition, the top of my list would be anything related to cloud data warehousing, right? Like if you think about it, what cloud, companies like Snowflake and products like BigQuery or Redshift, what they've done is that they've really lowered the adoption barrier. So now you have a lot more users, a lot more applications who can tap into data and try to glean insight. But what that means is that now, data pipelines are significantly more complex. So anything related to optimizing your cloud data warehouse, optimizing your queries, optimizing your data pipelines, with that definition, is something that absolutely needs to get automated. You can't manually automate tens of millions of queries throughout 24/7, but also something that the technology is absolutely able to sort of do today. So that would be the top of my list.
In a word, optimizing around the cloud warehouse. Great. Prashant, what would you add?
Yeah, so building on what Barzan and Arnab just said, so I look at data engineering into three major processes. One is on data integration, which of course is based on data pipelines. Number two is on data wrangling, which is on work on improving the quality of the data which you already have. And third one is on data enrichment. So I believe we'll have more questions on these three areas. So overall, I see the use cases for data engineering through AI could be on these three areas: integration of data into your canonical system. Number two, wrangling of the data to improve the quality of the data which you already have. Number three is on data enrichment, where you can get new sources of data, both columns as well as rows, and augment the data which you already have.
Wow, we're on a roll. How about you, Clinton?
Yeah, the three big areas we're seeing when it comes to data engineering are really around cost, quality, and performance. So data engineering problems related to these barriers to driving AI strategy are things like cloud cost management and data FinOps. These have become priorities due to the variable cost model of the cloud. So one of the things we hear is that cloud data spending is increasing. It has become the largest single and fastest growing workload segment on the cloud. The others around operations and troubleshooting, as has been mentioned, just because of the complexity of these data pipelines and all the integrated aspects. And then thirdly, around data pipeline and application optimization to achieve the performance and hit the SLAs that teams require.
Sue, what would you add?
Well, I think they've covered most of it, but the only thing that I would add is from a practical use case purpose, it's about data augmentation also, which probably is hidden in any one of those attributes or key points that others here made. But I think what I'm getting to is, when you're talking about data quality, it's easy to say, hey, but people are drowning in the kinds of data, the missing data, the transparency of the data, all of that, right? Which we hope that Gen AI would catch. But we also have to think about how we're training the models as well. So I know we're going to get to that. But for me, that's one of the things, other than the schema that I think someone already here mentioned. I think Arnab mentioned that is also part of it, because not everybody also has, by the way, metadata management. So while people are going from on-prem to the cloud, we make an assumption that many of these companies actually know about data management, data governance, and metadata management, which is not necessarily true. So before we even get to the data engineering workloads, we have to understand, that's why I said tied to the business outcomes, which I think Clinton mentioned, cost, quality, performance, right? Those are the kinds of language and verbiage that most people understand, and then tying it to those specific use cases, agnostic of course, the platform, the AI tool, or the industry that we're in.
Wow, that's a really powerful set. Let's review: migrations, cloud warehousing, optimization, queries, pipelines, data integrity or data integration, data wrangling, data enrichment, quality, cost, performance, particularly in the cloud environment where the costs are variable, and then data augmentation, getting the data fit for use. Wow, that's a great and powerful set of opportunities. So the question is, how are organizations using AI to solve these AI-driven data engineering tools to solve these problems? Barzan, why don't we start with you?
So I think one of the most impactful ways, I think, and as Quentin also pointed out, is like, cloud warehousing, because of that additional complexity and that additional amount of load and that ease of use that cloud data warehousing is provided, we're seeing that cloud spend is really getting out of hand. Like, you don't need to be a massive company to have a massive footprint on your Snowflake, for example, right? So this is exactly where we've seen companies have been able to really leverage automated warehouse optimization to significantly reduce their bill, at the same time boost performance, but also reduce the amount of load that the data teams have to sort of, the amount of workload that data teams are tasked with.
But how is that different than, people have been trying to manage costs in a warehouse for a long time. How is it different with AI?
So I think what's different here, like, if you think about like the database industry over the past 35, 40 years, there's been numerous tools that basically give you visualizations. Oh, like here's basically your performance. Here's what your cost is, right? Or even like some recommendation tools, right? But those things kind of fall on their face. Like if you go to a CFO and say, hey, how are you going to cut your Snowflake bill? They go to their data team and the data team says, well, you used this warehouse, you ran 10 million queries last week. This is what the cost of this is, right? So like to show people a visualization or to even go to them and say, hey, here's a bunch of recommendation, feel free to apply it if you like, is not very effective anymore in the modern scale of like cloud data warehousing. Because hey, if the engineer could actually stare at like 1 million SQL queries and say how to, these are the ones that you need to optimize, or here's how you'd optimize it, they wouldn't need a tool in the first place, right? Let's face it, right? But also now you have users around the world, right? Like you have people around the clock like hitting these data warehouses, right? So it's not, even if you basically had what I call an infinitely patient, infinitely competent data engineer, they would come up with the optimal setting for today, for this hour. There's no guarantee that an hour from now that's the optimal setting, or 24 hours from now that's still optimal, or a week from now it's optimal. But when you're relying on machine learning, you can analyze all of this stuff. Machine learning algorithms don't get tired of crunching data, but they can also do this continuously in real time, 24/7. I think that's the paradigm shift that we've seen a lot of companies have started leveraging.
So if the workload's going down, you size to a smaller warehouse and save some credits, and then workload goes up, or for example.
Exactly. Instead of sending an alert or text message to a data engineer like 2 a.m. and say, hey, now your workload went back up, please go back to your default size. Now you can sort of have these automated warehouse optimization solutions, track the load, track performance, and do it on your behalf according to your own cost and performance goals. So that's where we've seen companies have been very successful leveraging AI for sure.
Prashant, I'm seeing a lot of head nodding on this. And Arnab, we'll do you next because I see a head nodding there too. So maybe start with you, Prashant, go to Arnab, maybe.
Sure. Yeah. I love the way the discussion is going, especially Clinton laid out the 3-year dimensions. But one thing I feel that with all this, we have a huge problem to solve, which is reducing the cost and effort associated with data engineering. But at the same time, one of the tools which we have to solve this problem is AI. So AI, all said and done, is great, but it's not cheap. It is terribly expensive. So people have to understand that when we talk about AI, it's not something that go to ChatGPT just write a query. It's going to take a lot of money, and it's going to take a huge amount of carbon footprint as well, as we are living in the ESG days these days. So I was just reading a research from University of Massachusetts at Amherst, which says that a single model, which Sue was talking about just training a simple AI model takes about almost like 600 pounds of carbon that's emitted. There's almost like 5 cars of carbon emitted in their entire lifetime. So one thing is, it's all great about AI and everything, but we also have to factor in about what Clinton was talking about, cost versus performance. Do we have a real solid use case so that we get the benefits out of this? So, sometimes it could be very, very simple. Like not all problems need to be solved with AI. I think Barzan was talking initially. what can be automated and what needs to be automated. That's one of the fundamental questions which we need to ask before we start. Probably, I might be wrong here. I hope I'm wrong here. Chasing this shiny object called AI.
Yeah.
So Arnab, how do you see organizations actually using AI in this case, and and hopefully in an intelligent way to keep Prashant happy?
I think I can comment on what Barzan was saying, right? Elastic workloads, right? Automated elastic workloads management, right? With the high or low watermark, you change your workload automatically. You don't have to, rely on people, or you don't have to go to production diffusing bombs, right? So that's what I've seen, and I've actually what for me what's important is, and what people forget is, you'll have to look at cost and performance at the same time. You cannot optimize for one forgetting the other, right? And with AI there, right, you can look at it from both the lenses, and ensure that if you deploy the right model, do the right amount of data profiling, you're able to actually get to a elastic workload management system. So Barzan, thank you for that, and that's I would concur there. And I've seen a lot of my clients who are working with things like new age technologies like Databricks or Snowflake, etc., where you've got cluster sizing, or you've got warehouses to manage, moving that route.
Clinton, what would you say in this area?
I really appreciate all the thoughts already shared here. So as we talk with data engineers, how they're solving some of these challenges. So first, around workloads and budget, one of the things they're able to do is run more workloads for their same budget. And that's using cloud cost management and data FinOps. So they're doing things like chargeback and showback. And just by simply doing those things, some of the research is showing that companies are able to apply twice as many new approaches to improving cost management. There's also automated budget tracking and spend guardrails being put in place, and alerts, so that teams find out about their spending before the bill arrives, as opposed to retrospectively. In terms of SLAs and operations and troubleshooting, a lot of organizations that we speak with now are starting to use automated performance optimization, proactively alerting before something goes off the rails in terms of delivery timeframe, and then data pipeline optimization to make sure things are as fast and performant as they can be. And then finally, in terms of performance, organizations are able to launch applications much faster with speed, cost, and reliability optimization, but also automated pipeline bottleneck analysis and code level insights. So I remember, as a software engineer at Microsoft, the most frustrating thing is when a bug that you think you fixed comes back to you is still not resolved. So we want to help engineers, get through those and put these issues behind them.
So a lot of using the ability of AI and machine learning, the intelligence capability, the ability to monitor and evaluate, myriad, in fact, millions of things, and then come up with some better recommendations for what to do, and just beyond, humans' capability in terms of just the complexity of the problem, but also, as Barzan was talking about, the 7/24 nature. I mean, you solved it, and then 3 seconds later, that's no longer the answer. So it seems, Sue, would you add anything to this area?
I would, because here, as you asked about practical use cases in the real world, right?
Yeah.
So I'm going back to the fundamentals of what Prashant and others here have talked about, but specifically what Prashant talked about. You don't need AI for everything, right? So you first have to figure out where do you want to apply, because it is that cost performance balance, right? So that's the business case that you're going to build. The second thing is around the data set. The assumption is that data is simple. Data is not simple. There are various types of data, and data could be simple, and it could range all the way to being very, very complex. You take healthcare, you take industries that are very heavily regulated. I'll talk about healthcare, life sciences, and say banking, right? Because that's also my wheelhouse, but I worked in different sectors. You can also look at manufacturing and supply chain. But anyway, so let's just stick to that. So the second thing is, why should I be applying AI, or why should I be applying GenAI? this goes back to what are you trying to augment, right? So one is the cost, the workload balance that we're talking about, the cost performance, the quality. The second is actually being able to reproduce and also stabilize, right? So I'm talking about large, complex data sets, right? Now then comes the issue around data quality. So what can we easily say across every industry? I've worked in 19 industries, I've worked globally, where you can easily say, yeah, you know what, this is worth it because it can be scaled. I can rely on it being stable, quote unquote. I understand that there's going to be an iterative process, but the 24/7 that Barzan and others you have talked about is going to be reduced over time. So very a good example is anything related to, actually Clinton mentioned it, SLAs, contracts, right? Federal government contracts, state government contracts, contracts that are out there. So part of it is I can easily discern, things don't really change that much, especially when you're talking about government, right? If you talk about healthcare, there are some new programs that could be coming in. But regulatory things are more or less, quote unquote, there over a period of time. This is where you can start applying AI. This is where you can start applying Gen AI. This is where you can get input from different stakeholders. Remember that the end users are not just, economists or employees of a government, but they are all the way from the C-level all the way to the analysts. So when a data engineering group is actually thinking about the use cases, that's why I always say, think about the context, where you want to apply, why you want to apply, what is it that you're trying to augment or supplement, and then is it really, does it justify that cost, performance, and quality balance? You're on mute, Robert.
Robert, you're muted.
Okay, let's do that. I've got the gardeners out there and the big blowers and lots of leaves falling now in my neighborhood. Anyway, so
you always find the perfect time for that.
Oh gosh, yes, yeah. Let's. I could introduce you to Marco and Gabrielle. Anyway. Focusing, you talked about different types of AI. Are we talking about which kind of AI and ML techniques are we talking about? That's this whole domain. So as we think about the data engineering tools, how is this different than Chat GPT or other LLM type of AIs? I mean, what type of AI are we talking about when we're talking within the domain of doing data engineering? Prashant, is that something you're comfortable with?
Yeah, sure. I'll go first. In fact, the question is pretty broad, but I'll carve out the scope which is relevant to me or what I have seen with my clients. So I'll go back to the two big areas of data engineering where AI can help. Number one is data wrangling. So within data wrangling, one area where AI rules can help or AI solutions can help is on data imputations, where you have the missing data and we can find some rules where what missing data is there and how to populate it. That's number one. Next, number two, second area, which Sue mentioned and even I mentioned earlier, which is on data enrichment and data augmentation. There are two big areas which I can see AI can help is on feature engineering, number one. Next, number two is on synthetic data. So these are the kind of scenarios I think AI can help, and this is where I've been having those conversations with my clients or prospects.
You're again on mute.
You've talked about these challenges. What type of AI techniques under the covers when doing this data engineering?
So
it depends, right? So if you're looking at, say, large-scale migrations, etc., the one I alluded to beginning, right? In those cases, you'll probably be using Copilot and generative AI. You'll be using ChatGPT, etc. Now, if you are looking to do a product classification exercise, right? Data coming in from different master data sources and data for different products that's coming in. In that case, you'll probably doing a merge match kind of an algorithm that is something that you'll be using, right? So that, and if you are tracking costs, etc., right? It will be more of a predictive analytics, right? That you're going to be doing. So it could be generative, it could be classification, it could be predictive, and in various ways. So these are the few things I've seen in the market. The other thing, of course, I would also want to talk about a little bit is data lineage and data quality. The places where we could use AI. For example, in data quality, you'll have to use things like anomaly detection techniques. For example, if the sales suddenly goes spirals north, right, and you're not expecting it to go spiral northwards, right, then you'll have to use things like data quality. In data quality, you'll have to use anomaly detection techniques to understand whether it's actually an anomaly or it's a false positive, etc. So that's the other place. And in data lineage, what I've seen is imagine a brownfield kind of an environment where you're already in a messy environment. You've got thousands of pipelines, etc., running. There's no way for you to have that tracking or traceability. Auto discovering relationships between data assets is something I've also seen that, and I've also talked to my clients on.
So, but let's step back for a moment. Do the users really need to know which AI technique or modeling approach, or is it anomaly detection, or this type of machine learning, or this type of generative AI? I mean, if you're buying a product, a data engineering product that already has the AI techniques built in, doesn't that kind of, you don't really need to know the method that the software company used to create the product. So Barzan, Clinton, you guys are from software companies. Let's talk to you about what do you do under the covers with AI to actually solve the problem you solve? Start with you, Barzan.
Sure. So I like to sort of just like break into two parts, right? Like if you sort of put yourself in the data engineering team's shoes and then put yourself in the vendor's shoes, right? So as a data engineer, like what I used to teach my students when I was, on the academic side was like to sort of first map out where you are, like in terms of your analytics needs, right? Like, is the problem you're looking for? Because if you look at the whole life cycle, you go from detection to diagnosis to prediction, and then you basically want to detect, diagnose, predict, act, and then learn and repeat. But you don't have the full life cycle for every single problem, right? So it's really important as a first step. Like you don't need to know exactly down to the last formula of how ChatGPT is built if you're trying to just use it. But you definitely do need to know where you are in that life cycle. If you're looking for, if your problem is discovery or detecting when something's out of whack, then you want to be looking into outlier detection libraries and services and products, right? If you're looking for something that's predictive in its nature, then you have to sort of ask yourself, is this like open-ended problem? Then maybe I need to sort of just go and lean into large language models or Gen AI, right? They're really good at predicting the next open-ended sentence or image and things of that sort, but not every problem is open-ended. So maybe just traditional supervised or even unsupervised learning could help you there. But where we basically so that's the first part, right? Like this is where you want to be as a user of this technology. You need to know what is the problem you're trying to solve so you can evaluate the right type of solutions. But from a vendor side, actually, this is related to what Prashant was saying in answer to your previous questions, right? Like the vendor has to actually have a solution that makes sense for the problem. It doesn't really make sense for me to go and train a deep neural net to predict which coffee shop you're going to enjoy their coffee the most. It just doesn't pay off. Like I need to spend like $200 training this deep learning model that could tell you, hey, you're 5% more likely to like the coffee from this coffee shop than the other. But when we're talking about something like cloud data warehousing, instead of telling the data teams to go and, hey, go back to school and, take this machine learning class and then come and build your own library and then tweak it, you can actually buy a package from vendors who specialize in this. And then it's their problem to make sure that the cost of training those models and the impact of those models is outweighed by the benefit that they basically deliver to their customers. So one of the interesting things we kind of in this, like when you start to split the problem into knowing what your problem is, knowing what's a solution to it from a vendor side, one of the interesting dynamics, which is related to the cost of training machine learning algorithms that we found was that we basically kind of took away the cost risk from the customer. Like one of the things we tried to do was to tell the customer, you know what? Yes, training machine learning models is expensive, but so is running an over-provisioned cloud data warehouse. So whatever you basically save
Like, you pay 1/3 of it to the solution, and then you pocket the other 2/3. So I think knowing what the problem that you're solving is really important for the user, for the data engineering team. But then for the vendor, it's really important to understand how these models are used, how they're adopted, and how they're deployed, and how they're evaluated. So I think that's how I at least look at it from the two different angles.
Clinton, how about you? How do you think about that in terms of embedding AI inside your product, and so that the data engineers don't need to know what you're doing inside, as long as you're doing it well, doing what you do well?
And I appreciate that, Barzan. Yeah. So one of the things that we always think about in terms of AI is the value in the AI really comes from the data on which it's trained. So similar to ChatGPT, as you mentioned, Bob, or other LLM AI technologies, AI used by data engineering tools improve as they're trained on larger volumes of data. But unlike ChatGPT and other LLM technologies, purpose-built AI for data engineering is trained on millions of data pipelines and queries run on specific cloud data platforms such as Databricks or Snowflake, BigQuery, or Amazon EMR. And while ChatGPT can generate code based on static examples it has seen on the internet and other sources, a purpose-built AI can actually spot anti-patterns in code based on dynamic analysis of the organization's active metadata, including things like data tables and relationships, indexes, partitions, pipelines, and your cloud computing resources and other things. So it's really powerful when you can build an AI purpose-built for your data platform.
Thank you. So we've gone for a while now, and we've talked a lot about the opportunity. I think we can impute the benefits in terms of cost savings, better data quality, et cetera. Let's talk about the practical nature of implementation. Where do you start? What are good, what are some of the best practices? That sort of thing. Let's focus on helping the listeners be successful in doing this. So Arnab, why don't we start with you, since you, as you mentioned, you're out of the consulting world. We'll go to Dr. Su next.
So my entire thing is, okay, is it, is the lemon worth the squeeze, right? Do you actually, how much of time actually are you spending in training the model? How much of time, and at the end of it, how are you able to quantify the benefits, whether it's worth it or not? That's the first thing you need to look at. Do not force fit AI where it's not required. I have seen people, trying to just force fit AI just because it's cool. So that's what I would tell people to avoid, and that's what I've been telling my clients to avoid as well. Thanks.
How about you, Dr. Su?
So I think in terms of implementation of best practices, I think we talked a little bit about it here. I think the first question that Barzan already talked about it, what is your current state and where should you be deploying AI, et cetera, right? I think the second part of it is in the implementation, you have to look at the model integrity. And when whatever technique you're using, it doesn't matter. What is the model that you're building? What is the data that you're building it on? And how much can you rely, how confident are you about that model in terms of replicability, stability, et cetera, et cetera. So when you're talking about model integrity, you're going to talk about a set of inputs that are very, very important. So there's people inputs, there's the data engineering inputs, there's the tool, the different data sources, the cleanliness of that data, the quality of that data, the accuracy of the data, upon which perhaps you're trying to then at least discern a pattern or sets of trends, right? At a very minimum, you're going to try and do that. Then ties to the cost, performance, quality, et cetera. So I think in terms of implementation of best practices, the best practices that I have seen are where you have the data engineering team. I loved what Barzan said, actually. Here's the vendor group, and here's the data engineering team or the internal group, right? There are two groups, but remember that the business case where you're trying to deploy it has to tie to the set of stakeholders upon which you're trying to get to the business outcome. You're not going to build something, hopefully, that doesn't tie to revenue. People are not going to invest in that. So part of it is agnostic, again, of tool, technique, agnostic of whether you can create anomaly detection. The fundamental question is going to be is, what is a model? And is that model, can I rely on the integrity of that model? All the other things will fall in. All the sets of inputs, the sets of activities, the types of tools, techniques, etc., that you want to build it on will fall. If you can say, cohesively and coherently that I can rely on this model and I can replicate this model, and therefore I can justify the $10 million that yields $100 million revenue, right? So to me, that's the best practice that I have seen.
Prashanth, Dr. Prashanth, can you what do you have to say in terms of implementation success?
Yeah, this is great conversation. I'm loving every line of what people are saying here. Okay, I'll talk about I'll talk about my perspectives. So basically, taking over where Sue and Bazan left. First is assess your maturity, which is all about your capability, resources, and everything. So there is one saying I often tell my clients and prospects: there is no point in preaching religion to a hungry man. So you need to understand what your current capabilities are and what your resources that are available, so that before you talk about AI, ML, and everything. The first step is that, which is an extension of what Bazan and Sue said. Next, number 2 is start small, think big, go fast. This is how you build your use cases. So Sue was talking about impacts. I have a kind of a template where I ask my clients to follow this 4-stage template in building the use cases. The first one is, what is the problem? What is the problem you're trying to solve? Next, number 2, so what? What is the business impact? Talk about that. Number 3, now what? Now you talk about all the probable solutions you have to solve this problem, and AI could be one of the solutions to solve this problem. And lastly, then what? What are we going to do with this, which is to implement the solutions? I have this 4-stage problem, or 4-stage template to solve this second stage about building this use case. And lastly, the most important one, I believe, is what Sue said in the initial state when she opened the conversation, which is about governance. So very few people are thinking about governance as a kind of a last step in the whole process. So in my view, it should be one of the fundamental things. It should be discussed in every conversation, in every step. Governance has to be discussed. Not when I say governance, is not about policing and controls. It's about making sure that you strike a balance between kind of a data democratization and data protection. So it's about striking the balance between the two. You can't be unidimensional and go all the way saying that, hey, I want to talk about data as oil, blood, and all those things. But at the same time, you can't go to the other end where I say, I want to protect my data and not give it to anybody else. So you need to strike a balance between the two. That I call it as data governance. And today, when it comes to governance in AI, we are talking too much about, or a lot about, ethics and explainability, fairness, biases, all those things come into the picture. And before I leave, Rob, I just want to say one thing about the data part of it and its context to AI. The inherent state of data itself, there is a bias in the data that's captured. Yes. So that means the bias is carried forward to AI models as well. And here is one more reason why you need governance on the AI models, the data used in the models, so on and so forth.
Thank you. Clinton.
Yeah, so as we think about some of the challenges that data engineers and teams face, while working at Amazon Web Services, we had this idea of working backwards. So working backwards from the goal, or what's the objective, how do we get there? So the goal, or the outcome that we're seeing companies achieve, is running 50% more workloads for their same budget, achieving 99% of their SLAs, and launching applications 3 times faster. So the way that they're doing this is they're able to get the visibility that they need and correlate all of these error messages, logs, traces, to just be able to understand and then diagnose and resolve issues. So doing that manually is incredibly difficult, but using AI, suddenly it's a perfect way to sift through all this information. In fact, one organization I spoke with, they described it as not just finding the needle in the haystack, but also finding the haystack, because there's so much that they have to do to debug data analytics code, running in production to be able to discover these data layout and partitioning issues, code inefficiencies. So the number of new applications they can deploy in a given time period is restricted. But now with AI to help augment their decisions and quickly discover and address these issues, they're able to go much faster.
Thank you, Clinton. So Barzan, you've got a lot of customers who've achieved cost savings and query warehouse using warehouse optimization using your product, and so you've learned some things about good starting points and best practices, and on that journey to success. So, could you share with some of those that success formula?
Sure. To be honest with you, like I've sort of lived this question, right? Like this was the aha moment for me when I decided to sort of go from academia to put something in the customer's hands, right? Like for years and years, like I work with some of the smartest PhD students that you can imagine. Like we would publish these amazing, brilliant ideas in the top tier database and machine learning conference, and then ask ourselves, like, why are companies not adopting this, right? So essentially what it all came down was like only two keywords, really. Like all of this stuff is fun, but at the end of the day, what we realize is that there are only two things that matter. One is evaluation, and the other thing is adoption. Right? Like as a vendor, the only thing that matters at the end of the day is adoption. If the customer is not successful, if they fail to, see the value, if they fail to evaluate it, you don't get to that adoption. And from the customer's perspective, they adopt things when they can evaluate something, right? And they can evaluate it and decide on whether this solves the problem that they have. So what we basically, you're asking for the success formula. We actually broke it down into four things, right? Time to implement, time to value, cost to value, and risk to value. Those are the four things, right? The first one was like, how long or how much effort does a customer have to put in before they can actually put this in production? Like if the customer has to go and spend month and month collecting and cleaning data and learning things and migrating data, you're not going to get to that fast adoption. So that's the first thing that we figured it out. Like time to value time to implement has to be insanely short. The second thing, time to value also has to be really short, at least like to build a relationship with the customer, with the team, right? If you basically have to spend, a month defining what the success criteria is, and three more months evaluating it, and 3 more months after that deciding whether you've hit the success criteria, that's too late. The train has already left the station. Time to value has to be insanely short. Ideally, you want the customer to click on a few things and see actual value, actual savings. In our case,
Are you talking about that same day, that same week?
Pretty much, exactly. So like, if you can't really deliver that, you're not able to sort of gain that kind of attention from the team to trust you on the next steps, right? Like especially with cost saving, it's really important that the time to value has to be insanely short. Like, we started showing customers, hey, you know what? All I need from you is 30 minutes of your time. You don't have to give up anything. You don't have to put in any work. Within 24 hours, you're going to see savings, right? And then the third step was, okay, what's the, this is related to what Prashant was saying, like the cost of it. So what's the cost to value, right? Like if I have to spend, $20,000 to save $10,000, if I have to spend $2 million to save $2.5 million, it's not a very good ROI, right? So like we started thinking about, how about we just charge you 1/3 of whatever we end up saving you, right? Which is much easier when you're dealing with cost saving, but it's more complicated if it's about data quality and whatnot. So like always starting with money is a good place to start. Like if you're someone who's excited about ML, always like my recommendation is look for a place where they can actually show money. Like everyone understand the language of money. And then the last thing is that risk to value. How much as a data team, how much should I expose myself? How much should I expose my data? How much risk should I take on to actually evaluate your solution? Like if I have to give you access to my most critical and most expensive digital asset, which is my data warehouse, and let you see all the dirty laundry, and you may or may not be able to save me money, that's not a very compelling use case. So like figure out how you can actually deliver value by maybe just training your models on metadata. That's the fourth thing that we learned. Like how can we sort of train models without even, forget about storing customers' data, without even seeing their data? Can you just look at the telemetry? Can you just look at metadata and do this? So like again, time to implement, time to value, cost to value, and risk to value. That's at least the formula that seems to have worked for a lot of our customers.
Okay, well we've covered a ton. We've covered a ton of stuff today, all the way from why do it at all, different techniques, some really good best practices on how. Thank you everybody. We've been doing a great job here. Now, why don't we do some final remarks? Jonathan, you wanna cue that?
No, I think you just did. 30 seconds or less. Arnab, let's start with you, and please keep it brief.
Okay. You want me to go first?
Yeah.
Yeah, please. Any final thoughts, takeaways you want to leave the audience with?
So, I mean, to sum it up all, right? It's like AI can get you there faster, better, cheaper. But when you're looking at use cases, please choose them very judiciously. That's all.
Okay, excellent. Barzan.
Barzan?
I think these are some of the most exciting times to live in, right? Like in terms of AI and what you can achieve with it. So like if you have an opportunity to save costs, if you're in a place to actually improve data quality, if you're in a place to actually improve performance, leverage some of the amazing things that are out there. You can really improve what you and your team can do. You can improve your productivity and deliver a lot of value to your company.
Well said. Clinton.
Yeah, thank you so much. So we are seeing customers really start to leverage AI to solve their challenges. So we've seen a global logistics company save 70% on their cost efficiency in just 6 months. And they're upskilling their data teams, enabling thousands of engineers to take advantage of best insights from previous use cases. So I would just suggest use a crawl, walk, run approach to create a scalable operating model for your business and start with a single use case so your team can easily measure success.
Thank you very much. Dr. Prasanth.
Yeah, I'll take where Barzan left. He talks about the 4 things. I'll talk about 3 things. The first thing I agree with him is the language of money. Nothing sells better than the language of money when you talk to your prospects and clients. 3 things matter. One is, how does this solution improve the revenue? Number 2, what can you do to reduce cost? Number 3, what can you do to mitigate the risk? And the thing which brings all these 3 things together is customer and the customer's customer. So if you can put a value proposition in use cases by taking care of your customer and the customer's customer, things will fall in place. And I have discussed a lot about the what and the why part of it in today's call. So if you want to know how to do this, so this is my book on data quality. And this is my other book on analytics best practices, which was ranked the best analytics book of all time last year. So you can read more and get more knowledge.
Excellent. I think you jumped the gun on the self-promo, but that's okay. Dr. Sue, final thoughts on the topic.
I love it. And I think we all got a text from Prashant saying he's going to give those 2 books to us for free. So thank you in advance, Prashant. Thank you for that. So yeah. I just love what everybody said, from Clinton to Barzan to Arnab and Prashant. The only thing I would add here, and I was thinking about this, is, we didn't talk about human-centered design and design thinking. Prashant mentioned it towards end, customer and customer. Think about the customer and the customer, right? So when you're thinking about that in your design thinking, in your human-centered design, involve different stakeholders, kind of limit the frustration that you're going to come down the road. So by engaging key stakeholders in that design, so that when you're building those models, it'll really help you get to those 3 different things. And the one last thing, in particular industries like healthcare and in other industries too, they've actually come up with a risk value framework. So what Barzan and Prashant talked about, that is already being applied. They're only looking at risk, forget cost and they begin there and from there. So pick one paradigm that works for you when you're thinking about building a model or training a model set.
Excellent. Thank you very much. And last but not least, our moderator, Robert Eve. You have anything to add?
Well, I've spent a career in data management, enterprise software. And it really, to echo Barzan, it's the most exciting time. We keep going through these generations, mainframes to minis to desktops to the internet, distributed computing, distributed data. It's so great in terms of the business opportunity, but I think that, we really need additional tools and capabilities to make it all work and drive the value, our customers' value. And so I think we've got a lot of good inputs today, and I appreciate everyone's time.
I appreciate your time as well. Thank you for moderating, Robert. Before we wrap things up, I wanted to give each of our panelists one last opportunity for some self-promotion, whether they'd like to plug their book, a podcast, LinkedIn profile, and certainly their company solution. We'll go back around, same order as last time. Arnab, let's kick things off with you. Arnab, I think you're on mute. Here you go.
So can you guys hear me?
Yes.
Yes.
So we at Credence, of course, we are an AI solutions company with a lot of data engineering. We use an accelerator-driven approach to bring AI closer to our customers and do it faster, better, cheaper. Please do look us up, and happy to engage in a deeper conversation. Thank you.
Thank you very much. Barzan, anything you'd like to plug quickly?
I'm not big on self-promotion, but if you're using, Snowflake in any capacity, if you're using BI tools, if you basically spend a lot of time figuring out to maintain your cloud data warehousing costs or improve the query performance, I encourage you to go to Kibo.ai, book a demo, get a free trial. Like with 30 minutes, our customers are being able to, cut their Snowflake costs by 30% or more, and it's a set and forget it. It's like everything that we talked about today. If you're interested, I encourage you to just go to Kibo.ai and explore it out for yourself. Thank
Excellent. Thank you. Clinton, where would you like to send the audience?
Oh, thank you so much. It's great to be here. And if you're working with data and want to learn more about how to leverage AI, take a look at Unravel Data. So Unravel is a purpose-built solution for data observability and FinOps for Databricks, Snowflake, BigQuery, and others. And we offer a free account. So feel free to visit us at unraveldata.com to learn more.
Thank you. And Prashant, you already mentioned the book. Anything else you want to quickly mention?
Yeah, I'll talk about my other role which I play, which is as a consultant. So we, in my company, we have helped companies get value out of data and analytics by increasing their revenue and profit by 3 to 9%. So if you are interested to know more about this and see how we do it in the 8 stages of the data analytics lifecycle, reach out to me. And if you don't want to hire me and want to try, look at my books.
Sounds good. Sue, how about you? Anything else you'd like to?
I just have to learn a lot from all of you, especially Prashant. But I think my main thing here is don't be afraid to ask. Like others, I'm not going to plug anything. I do think that watsonx is a great prefabricated solution, but in general, I don't necessarily plug. There are lots of different solutions out there. Make sure that it suits you and what you're trying to get to. And if you have any questions at any time, don't feel afraid to ask. That's how I learned, right? And what I've come to and you can look me up on LinkedIn, but what I've come to a conclusion is that if you don't ask, you wouldn't know. So ask, practice, learn, go get your certifications, whatever you need, and go educate yourself. That you don't need to be in data, you don't need to be in analytics, you don't need to be in AI, you don't need to be a data engineer for you to learn and to grow yourself as well as your company.
Excellent. Thank you very much and well said. Robert, final thing, anything you'd like to tell the audience to promote?
Yeah, so you can reach me on LinkedIn, Robert Eve, or you can find me on Insight Jam. I'm a solutions review expert insider, and you can find my area there. Just really appreciate the opportunity to speak with everyone and participate in this panel. So track me down if you want to talk more.
Thank you again for your time and for moderating. That will do it for this panel, but we hope you stay tuned for the very next one coming up in just a few short 60 seconds or so. Data management, automation, tools, and paradigms. You don't want to miss that. So I hope you stay tuned to all of the Solutions Review channels. But for now, for us, thank you for watching and listening. Thank you again to our experts here. And we will see you next time.
Bye, everyone.